started with this here. We're going to get started with the chapter 3.6. This is the last section of the chapter we're going to cover before the test. And it's with quadratic formula. It's the quadratic formula. This is the last way we're going to have to solve quadratic functions. And the equation is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. This here is relating back to our quadratic equation, ax squared plus bx plus c. And we need it equal to 0. Yes. Yes. So it's working with these here. Ax squared plus bx plus c with this here, and that would give us the solution. So let's look at this here. Let's look at the first example. Now we're given this here. Solve x squared plus 3x equals 5 using the quadratic equation. Step 1. Get it equal to 0. The equation needs to be equal to 0. Because if we're going to use the quadratic equation, it has to equal 0. Well, does this equation equal 0? No, it's equal to 5. So if I want it to get equal to 0, I need 2. Step 2, plug A, B, and C into the formula. Plug A, B, and C into the formula. And the formula we're talking about is this quadratic equation. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So we have this here. Now, again, this is all going back to our ax squared plus bx plus c. So looking at this equation, the first thing we have is negative b. Well, what's the value of b? The value of b is positive 3, because ax squared plus bx plus c. The value in the b spot for this equation is 3. So we'll have negative b plus or minus. Our next term is b squared, so we have 3 squared minus 4. Our next letter is a, because we have ac. Well, the value of a, there's not a number in front of x squared, so it would be 1. And the value of c is negative 5 over 2 times a, or 2 times 1. We plugged in the values of a, b, and c. A was 1, b was 3, and c is negative 5. Any questions on anything we've done so far? Y'all ready for step number 3? Simplify it. We're going to simplify it here. Well, this is just going to be negative 3, because we can drop the parentheses and it's just negative 3. Now, what I would do next is everything inside the square root, I wouldn't take the square root of it yet. But everything inside the square root, we can plug straight into a calculator. So parentheses 3, close parentheses squared, minus 4 times 1 times negative 5. Plug it in and hit enter.
So we wouldn't do the plus or minus right now. I would just be plugging in the 3 squared minus 4 times 1 times negative 5. Because there's really not a plus or minus button in the graphing calculator that we can use. Did y'all get 29?
Yes. Now, I'm going to sound bad on the audio. The last thing we have is 2 times 1, which is 2. Now, at this point here, I would utilize the yellow calculators if you're not used to simplifying radicals and leaving them in simplest radical form. So does anybody know if we can take the square root of 29 and get a whole number? No. There's not a perfect square that is a factor, but one of the factors of 29, so we leave it. And since there's not a greatest common factor between the terms outside of the radical, our first term and the denominator, we're done. That's it. That's all we have to do for this here. Now, a big idea of math, as you've noticed, is probably going to want, and it's going to want 2 answers for this here. Well, the first one we can give it is negative 3 plus the square root of 29 over 2. And the other is negative 3 minus the square root of 29 over 2. It's just taking that plus or minus and breaking it up into its 2 parts. And again, on the test, I will take the plus or minus, this version of it. Big idea of math is going to want both. Questions on this here? Do we like this better than completing the square? A little bit. I mean, it's not as easy as graphing, but it's probably the second easiest way we've gone about solving these, yes? This equation will be utilized in the next chapter as well. So let's look at the second one, if there aren't any questions on the first one. Solve 3x squared plus 4x equals 10. So our first main step, is it equal to 0? No, so let's get it equal to 0. What do we need to do? We need to subtract 10 from both sides so that this thing will equal 0. Now, none of these are like terms. 10 is not a like term to x squared or x. So we just have 3x squared plus 4x minus 10. So now it's equal to 0, yes? Since it's equal to 0, we can use our quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative b. Well, what's the value of b? The value of b is 4, yes? So this is going to be negative 4. Inside we have 4 squared, b squared minus 4. A, the value of a this time is 3. And the value of c is negative 10, all over 2 times a. So again, this is all working back to our ax squared plus bx plus c equals 0. A is going to be in front of the term with x squared, b is in front of the term with x, and c is the number without a variable. It's our constant term. Any questions on this so far? Any questions how we plugged any of this in? We're good with this here? Yes? Okay. So we have negative 4. And again, I would type everything that's in the inside the radical in first. So that v squared minus 4ac, or 4 squared minus 4 times 3 times negative 10, I would type that into the calculator first and see what we get. And see what we get there first. $139? No. 136. And this is over 6. 2 times 3 would be 6. Now, again, the yellow calculator will do the square root of 136 for us. The graphing calculator is going to give you some ugly decimal. Four times 34. That's 2 times 17. Okay, that's... Well, 136 is 4 times 34. Well, the square root of 4 is 2, and we have the square root of 34 left over. At the TI-30XS, those yellow calculators will simplify that root. So you can type the square root of 136 in the calculator. It'll tell you it's 2 square root of 34. It'll simplify it down for you. Any questions on this here? We good with this here so far? Now, most likely, I have a feeling that Big Idea Math is going to count this wrong if you put this as an answer. Because if we look at this here, is there a greatest common factor between these two terms and the one on bottom? Is there a greatest common factor between all three of these? 2. There's a greatest common factor of 2. So one way we can do this is I can factor the 2 out, which would leave us with negative 2 plus or minus the square root of 34 over 6. So we can factor that 2 out. Well, 2 over 6 is going to reduce to what? 1/3. So really, x is equal to negative 2 plus or minus the square root of 34 over 3. This is most likely the answer that the Big Idea Math is wanting. It's wanting it simplified all the way down. So really, if we need to see if we simplify or need to simplify it, I'm going to look at these 3 numbers here. It doesn't matter what's inside the radical. If there's a number inside of a square root, we don't care about that. The number in front of the square root, number in front of the plus and minus, and the number on bottom. If all 3 of these have a common factor, we need to simplify it. If only 2 of them do, we leave it as is. It has to be all 3. Does that make sense? So if all 3 have a common factor, we'll simplify it. If all 3 don't, leave it. Leave it. Questions on this here? Let's see here. Are y'all starting to get the hang of this here? Yes? Do we need to see another example of 1, 2, or, because we're going to do 2 more. Y'all feel pretty comfortable with these here? Yes? Okay. We're going to skip those and go to this one here. This one here. So it should be C. Letter C. Letter C in your notes. Solve 25x squared minus 8x is equal to 12x minus 4. We want to solve this here. So the first thing we need is this equation that needs to be equal to what? 0. Well, it's not equal to 0, is it? So we need to get it equal to 0. So what do we need to do first? We need to then you subtract 12x from both sides. And when we do that, well, 25x squared doesn't change. But 12x, negative 12x and negative 8x, well, those are like terms, so we would combine those, which would give us negative 20x equals negative 4. Now we need to add 4. So we get 25x squared minus 20x plus 4. So now do we have this equation equal to 0? Well, yes, we do, don't we? This is equal to 0. Now, these first two steps, minusing 12x and adding 4, we could have done them in either order. You could have added 4 to both sides and then subtracted 12x. It doesn't matter which order we do it. Our main focus and goal is to get the equation equal to 0, which we did. And now that we have that, we can use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, I am not expecting you, and you do not have to memorize this formula at all. You do not have to memorize this formula. You can just write it down on your review sheet, and you'll have it for the test. And again, this is going back to our ax squared plus bx plus c equals 0. So the first thing is our b, the value of b. So what is the value of b? It is negative 20. Now this here is one of the steps I kind of do all together because we're plugging in negative b, yes? Well, if the value of b is negative, it becomes positive. A negative and a negative make a positive. So really, whatever the value of b is outside, it's switching. Since it's negative in the equation, negative b is going to become positive because a negative and negative would make a positive. Square root. Negative 20 squared minus 4. Again, so here the value of a is 25, and the value of c is 4. All over 2a. Well, what's the value of a? The value of a is 25, yes? What's 2 times 25? 50. So when I solve these here, there's two things I will do all at once when I plug them in. The negative b, because it's really just changing the sign, and 2a, because we're just multiplying by 2. Those are not overly complicated steps. I do them at once because they're not too bad. If you need to rewrite this out, needed to rewrite out everything, negative 20 plus or minus the square root minus 4 times write it out and then go to this step, write each of the things in and then simplify, that's fine. There's nothing wrong with that. Because if that helps you keep track of everything, do it. Okay. Now that we have that, we need to simplify everything inside of the square root. So we need to find out what 20 squared minus 4 times 25 times 4, or negative 20 in parentheses squared minus 4 times 25 times 4 is. We get 0. It works out to be 0, and that's possible. But what is the square root of 0? Yeah, so we have 0, so we have 20 plus or minus 0. Does anything really change if I add or subtract 0? No. So I can pretty much just drop that, and we have 20 over 50. Can I simplify 20 over 50? It becomes, so x is 2 over 5. We have one unique solution. We got one solution. Questions on this here? So here it worked out we had one solution. Any questions on this here? Any questions on anything we've done so far? This is the last one we're going to look at. of this type. And so far, we've had equations with two real solutions and one real solution. And if you notice the header for this here, imaginary or complex. So we have an idea of what we're going to get solutions-wise for this. Well, the first thing we need to do is we need to get everything on the same side of the equal sign. We need to get everything on the same side of the equal sign. We need it to be equal to 0. So what's the first thing I can do in getting this equal to 0? We can subtract 13 from both sides, which gives us negative x squared plus 4x minus 13 equals 0. Now, when we were factoring, we wanted the value of a to be positive, but with the quadratic formula, it doesn't matter. A can be negative. That's fine. So we got it equal to 0. So the next thing we need to use is we need to use the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. We need to use this here. Well, the value of b for us here is 4, so it would be, so negative b would be negative 4 plus or minus the square root of b squared, so 4 squared minus 4. A is negative 1 and c is negative 13. All over 2 times negative 1, 2 times a. Well, a is negative 1, and 2 times negative 1 would be negative 2. Any questions on any of this here so far? Any questions on anything we've done so far? Now, at this point here, we can type everything inside the radical into the calculator. So 4 squared minus 4 times negative 1 times negative 13. And if we type that in, we get negative, what would that be? We get negative 36. Now, the yellow calculators, the TI-30XS, will not take the square root of negative 36. They just won't do it. This is part of the reason why I simplify what's inside of the radical first, just in case it comes out to be negative, because the yellow calculators will do this if we manipulate it a little bit. What do I know about the negative inside of a radical, or a square root, really, inside of a square root? It's going to come out as I. Anytime we have a negative inside of a square root, it's going to come out as I. And once we take that out, what we're left with is what? The square root of 36. And what's the square root of 36? 6. So we have 6i. So again, I'm noticing something between our three terms. Is there a greatest common factor between negative 4, 6, I, and negative 2? There's a greatest common factor of 2. Now, we can do like we did before and factor 2 out. Or I can divide the negative 4 and 6i by negative 2. We can do that with both of them, and it'll simplify. Because negative 4 divided by negative 2 would be 2. The negative and negative would make a positive, yes? 6 divided by 2 would be I. Now we divided by a negative, yes? So the sign in the middle would be plus or minus. Anybody a little confused with that? So let's look at it individually. Because what we have here is plus or minus 6 divided by negative 2, yes? That's really saying I have 6 divided by negative 2 and negative 6 divided by negative 2. Well, 6 divided by negative 2 is negative 3, yes? Negative and negative would give me a 3. So in this plus or minus here, I'm going to actually color coordinate this. Let's say negative and a positive. Well, because I divided by a negative, the positive is now negative. Because they switch signs, yes? Well, a negative and negative make it a positive. So the positive became the negative and the negative became the positive. They switched, but we still have both. So that's kind of interesting with plus or minus. It still works out, but we can just get the plus or minus. It switches. Questions on this here? Any questions on anything we've done so far? This is the last thing we're going to talk about, the discriminant. The discriminant. The discriminant is our negative b, or b squared minus 4ac. Now, if the discriminant, the b squared minus 4ac, is greater than 0, we will have 2 real solutions every single time. If b squared minus 4ac is greater than 0, we'll have 2 real solutions. If b squared minus 4ac is equal to 0, we have 1 real solution. And if b squared minus 4ac is less than 0, it's a negative number, we have 2 complex solutions. So it really determines what kind of solutions we will have. And so we can use it to kind of see what kind of answers am I going to have? What are we going to expect to see show up? And we can use that. So if we look at this first one here, x squared minus 6x plus 10, I can use the discriminant b squared minus 4ac to kind of see what values will I have. What values am I expecting to come out? So here the value of b is negative 6. So we have negative 6 squared minus 4. A is 1 and C is 10. And at this point here, we can plug this into the calculator. You can type in the negative 6 squared minus 4 times 1 times 10. And if you type this in the calculator, you get, or should get, negative 4. You should get negative 4 if you type this in. Because 6 squared would be 36, and 4 times 1 times 10 is 40. So 36 minus 40 would be negative 4. So the discriminant here, b squared minus 4ac, that would be what? Less than 0, yes? So what are we going to have? We're going to have 2 complex solutions. We're going to have 2 complex solutions because the discriminant is less than 0. If it had been equal to 0, we would have 1 real solution. And if it's greater than 0, we would have 2 real solutions. Any questions on any of this here? We good with this here so far? Well, there's a good chance they might ask us to solve this here. And that's just using the quadratic equation. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. For us here, the value of b is negative 6. Well, the negative and negative would give us a positive. Well, a is 1, so 2 times 1 would give us 2. And that's just pulling it from the equation. Now for this here, I really don't have to type in Negative 6 squared minus 4 times 1 times 10. Because don't we know what the value of that is? What is the value that would go here? Negative 4. We already figured out what the discriminant is. That term inside that square root is going to be negative 4, because that's what it is. Now we just need to simplify. Well, the negative is going to come out as I, and the square root of 4 would be, there's a greatest common factor between these three, isn't there? 6 divided by 2 would be, 2 divided by 2 would be I. Now, it works out well that way because the denominator fully simplifies with the numerators. But sometimes if it doesn't, like we saw in one of the first ones, it might be easier to just factor it out. Any questions on any of these here? How do we feel with these here? How do y'all feel about determining the number of solutions given what the value of the discriminant is? B squared minus 4AC. Do we need to see another example for this here with the discriminant? We can do one. Because if we look at this here, negative 6, or x squared minus 6x plus 9, well, b squared minus 4ac. Well, the value b is still negative 6 squared. Minus 4 times 1 times 9. And we can type this into the calculator. Now, negative 6 squared is still going to be 36. Well, 4 times 9 is 36. So this here is equal to 0. Since the discriminant is equal to 0, what do we have? How many solutions do we have? And it is a real solution. One real solution. And that's how we would use the discriminant to find out the number and type of solutions we would have. Questions on this here? You feel pretty good with this here? Awesome.